Hello everybody and welcome to your Chem 113 review on physical and chemical changes. My name is Jason and I work for the ASU Tutoring Centers. So now let's first define what a physical change is and what a chemical change is. So a physical change, basically what happens is your substance might look different, but it's still composed of the same atoms. So looks different, but the atoms and molecules have not changed. Have not changed. Okay, so although the structure might look different to the human eye, the actual, if you were to like zoom in with an electron microscope and look at the atoms and the molecules that it was originally made of, it's still made of those exact same atoms and molecules. Okay. So examples of a physical change would be something like a state change. So maybe it went from solid to liquid or liquid to gas, right? The molecules are still all the same, it just looks different. Or just, I mean, anything that really just looks different, but it hasn't really changed much. So like slicing things in half, changing the quantities of things, all of that stuff is still just a physical change. Whereas a chemical change, a reaction has occurred. So you have now different atoms or molecules. An actual chemical reaction has occurred. So if you took an electron microscope and looked at it before and after, it would look different on the molecular level. Okay? Typically, things like that involve some form of like smell change. So you might smell something different. It might give off some heat. It might give off some light. So anything that has sort of an energy to it, right? Like heat and light have sort of this energy to it. A change in smell is something chemical going on. So anything like that is typically a chemical change. So let's look at all these examples we have, and let's deduce whether it's physical or chemical. So chopping a piece of wood. What do you have beforehand? You had wood. What do you have afterwards? You just have more wood, right? You just chopped it maybe in half, and now you have two pieces of wood, but it's still wood. If you were to zoom in molecularly, it still looks exactly the same. So this is definitely a physical change. Okay. Melting ice. What is ice? Ice is just water that is frozen, so water in the solid state. If you melt it, you just make water in the liquid state. All you've done is change the state that it's in, but if you zoom in, you still have H2O molecules before and after. So this is also a physical change. Okay, a rotting banana peel. So this one would be an example of a chemical change, right? You still have a banana peel before and after, but how does rotting occur? Well, rotting typically occurs, the oxygen in the air will react with the banana peel and give some sort of, chemical reaction. That's how you get like the mold that grows on it. That's how you get that gross smell that comes out of it. It's reacting with the oxygen. So if you zoom in before and after, before you just have pure banana peel, whatever that's made of, lots of carbon. Afterwards, you have some, banana peel, but there's other stuff going on in there too. It's not just pure banana peel anymore. You now have that mold growing on it. You now have a difference in its actual chemical structure. Okay, shredding paper, very similar to chopping a piece of wood. Before you have paper, afterwards you have paper. It is a physical change. Okay, exploding fireworks. How do fireworks explode? There's a chemical reaction that has to occur, right? It kind of goes into this heat and light idea. When you have the firework before it explodes versus after it explodes, a lot of heat is released, a lot of light is released. That's how you get those beautiful lights in the sky when fireworks go off. Okay, so exploding fireworks is an example of a chemical reaction. Usually anytime there's an explosion going on, there has to be something happening chemically. And then when you're burning wood, again, this has a lot to do with heat, right? Beforehand you have wood, but afterwards you have this sort of like charcoal kind of thing. So there's a change in its molecular composition. You look before, it's just a bunch of wood. a lot of carbon in certain arrangements. You look afterwards, you get charcoal, which is still carbon, but the arrangements of those carbons are probably different. So this is definitely a chemical reaction. Again, anything involving heat, typically a chemical reaction. All right. Well, thank you very much. As I mentioned at the beginning of the video, I work for ASU Tutoring Services. If you want more information about the free resources we offer on all 4 campuses and online, please check out tutoring.asu.edu. If you want more videos like this that go over specific concepts from your course, or maybe you want to see what upcoming review sessions we have for your course, please go ahead and check out that link below. Thank you all again, and I hope you have a fantastic day.